My name is Manny Osaba. I'm from Jupiter, Florida, and I'm finishing up my master's with the sports management program this summer. I've been an FSU diehard my entire life. That's why I'm honored and excited to tell you about a campaign we have involving FSU sports analytics. I'm leading this initiative through the FSU Coaches Clubs to raise funds for several of our women's sports programs that were affected by COVID-19 budget cuts. That's why we need your support to keep sports science technology like Whoop bands, vert, and catapult vests on the field and in use. Investing in sports analytics is one of the best investments at this university. Whether we're maximizing the work rate of our players or resting them at key moments, it's all about working smarter, not harder. I hope you can join us in making FSU a leader in sports science. Support this campaign at fsucoachesclubs.com. And as always, go Noles.
Hi everyone, my name is Alok Pattani and I'm a data science developer advocate at Google Cloud. Thanks so much for having me speak today at the Florida State University Sports Analytics Summit. I'm excited to be here today to talk to you about sports analytics and data science. I'll go through some of my experience in the field, both here at Google and previously at ESPN, and then talk about sort of the big picture of sports analytics, how to get involved, and some of the areas of opportunity that I see going forward. My sports analytics background, let me go through some of this here. So I grew up in Connecticut, and then I went to Boston University where I majored in statistics. And at the time there, I thought I was going to go maybe major in math and do a PhD, but I also became very aware of this sort of Moneyball movement, read the book of Moneyball, read Basketball on Paper, and started to realize, wow, there's a growing field here of people working in statistics and sports. At the same time, I got involved with the ESPN Stats and Information Group as an intern, then as a temp, and then eventually got a full-time job upon graduating from BU. While I was there, they started a sports analytics team, the first of its kind, and I was fortunate enough to be in the right position to be a founding member of that team and worked there till 2016. Later in 2016, I came to work at Google and then got back into the sports sort of realm of things early 2019 when I took my current position at Google Cloud, which I'll discuss a little bit more going forward. Also participate in other consulting, advising with different teams and things over the period of my decade plus in sports analytics. It's been a true passion of mine to work in this field, and I'm really happy to share some of the things I've worked on and some of the other things that may be useful to those of you who are interested in getting into the field or building on careers in the field in this presentation. So let's start with my time at ESPN Sports Analytics. As I said, the team got started about a decade ago, and our first project was to build a rating system for NFL quarterbacks. That became the total quarterback rating. So when we started, we were pretty new at the game of building metrics, especially at a content company, which is like ESPN. And we were pretty aware of sort of the frameworks and things that were around for NFL, but we wanted to put a bunch of things together. So the first thing we did was we thought about expected points. At this point in sort of the football analysis world, expected points is fairly like well known as a framework. Everyone uses it in both NFL and college football. At the time, we had Brian Burke at Advanced NFL Stats, later came to work at ESPN, who was using it, and a few others who had referenced it. So it was a great thing for us to build upon and build our own model of using NFL data we had and form as the backbone of quarterback rating. That's important because, yards are important in measuring quarterback play, but not all yards are created equal, right? So if you get 5 yards on 3rd and 4, that's good. That's a first down that keeps the chains moving. If you get 5 yards on 3rd and 9, that's not that great. Probably going to punt the ball or kick a field goal and not keep moving towards a touchdown. The next interesting piece of total quarterback rating is that we wanted to do some division of credit. So again, fortunate to work at ESPN, we had resources for people who tracked every single NFL snap. They were tracking things, again, at the time that were differentiating, like how far the ball went in the air versus how much the receiver ran after the catch, whether the quarterback was under pressure or not, whether an incompletion was a drop or an overthrow, and those sorts of things. And that allowed us to get more fine-grained on each individual play at evaluating quarterback performance. You see some other question marks I have there about clutch weighting, opponent adjustment, and scale. These were things that kind of influenced how we thought about the rating, both at the time and then as the rating evolved over the course of several years. Clutch weighting refers to whether certain parts of the game should be weighted more heavily than not. Initially, we had a framework. Eventually, we backed it off and made it so that it was less important. And there's reasons for both doing that in terms of storytelling, in terms of like, hey, the biggest plays are the biggest plays, and also in terms of consistency and trying to isolate signal from noise, maybe not weighting as much. Opponent adjustment. So when we did this in the NFL, over the course of the season, teams play different opponents, but you don't have any truly bad teams, and you don't have certain disparities in schedules like you might in college. So this was something that was added into NFL QBR later after we adapted it for college. And then the scale. You can see on the right there, I picked the Florida State quarterback, Jameis Winston. There's some scores. They're actually on a 0 to 100 scale. This was thought to be as something that our sort of people, content people at ESPN, those on air, really preferred because the NFL passer rating, which was sort of the incumbent rating at the time, was on a scale that they found hard to understand, about 0 to 158.3. So we were, we felt pretty good about putting it on a 0 to 100 scale and developing from there. Okay, going forward with football, we were then able to build with college football. For those of you at Florida State, this might be even more interesting because, as you know, Florida State, big college football powerhouse historically. So at the time we were working on this is when the college football playoff was new. And, we were talking a lot about how should we measure the best teams. And quickly we realized we were in a situation where the answer wasn't clear to us, and it wasn't because of some sort of data problem. It was because of a philosophical issue. Should we be picking the best teams or the most deserving teams? So what ended up happening is we decided to create a series of metrics, some that would answer more about the best teams and some that would talk more about who's most deserving. If you think of a typical power rating, and in our case, we developed one called the Football Power Index, FPI, those are used to make projections. So in order to project, you want to look forward, and therefore you want to isolate a little bit more about who are the best teams. What parts of their performance are repeatable? What other things do you know about the team that might influence how well they play going forward? It's not the same as what they did going backwards, though it's related. It's a lot about just predictions. And these, especially nowadays, are become typical sort of machine learning problems where you gather some past data, look at results, backtest, and try on holdout samples and try to maximize your prediction accuracy or minimize your error. But then there's another question. Who makes the playoffs is not always who's the best in sort of a who would beat whom scenario, but it often has to do with how did teams do, who beat whom. Even if a team won in an unsustainable way by 1 point at the end of the game, that still matters. They still won the game. So what we realized there was we needed some more backward-looking metrics to measure resumes. And that's where we developed metrics like strength of record and secondarily game control. Strength of record has kind of emerged as like a very interesting concept since then, and applies a lot to sports where you do want to measure the quality of a team's resume. So typically college football, college basketball. And what it does is it says, how hard is it to achieve this team's record given its schedule? It starts with, in the case of the ESPN version, FPI, and then says, okay, look at each opponent, how hard are they to beat? That's their FPI. Where was the game? Home or road, neutral, and some other factors, and then determines how likely it is for that team, for sort of a top team to go against that schedule, have that record. So what you'll see on the top left here is some blind resumes. These were what we were using at the time to sort of generate this interesting discussion. Is, in one case, a team might be really good in strength of record. You see this team is 4th, but actually much worse in FPI. They're 20th versus this team that was 2nd in FPI, but behind them in strength of record. And who would make the playoff and how. This is with the hypothetical 2013 season, which is now a bit old. But you can see how, one team looks very obviously like maybe better if you just look at the blind resume. But then if you go back and think about the season, you can see that Team C did not, at least by the polls, rate as highly as the other two, despite the fact that their metrics looked pretty comparable or even better. And then since then, and this is something that ESPN has worked on before, since I've left, you can talk about projecting the playoffs. That's a whole nother problem, right, in college football, where a bunch of humans decide, using some data and using their observations, the eye test, so to speak, about how teams are, they decide who makes the playoffs. So if you want to project who makes the playoffs, it's not necessarily about your metrics, FPI, strength of record, or whichever ones you have. It's about what do you think humans would do. And if you have past indication of human behavior, that's one input, but maybe the committee will be different this year. Or maybe it's a year like 2020 where there's a pandemic and things are very different. How will team committee members judge teams with different numbers of games on their schedule, right? So this is a challenging problem. I think ESPN Analytics as well as 538 have made good strides in this area in recent years. But you can see how the whole question of the playoff results in a bunch of different questions that can be answered in this way. Keeping the theme of college football. So this is not just to kind of pump up my past self, but when I was working on college football again back in 2013-14, this is sort of when FSU was last really dominant in college football with Jimbo Fisher, Jameis Winston, and others. So we had some really good usage out of total QBR related statistics, right, for Jameis Winston, who won the Heisman Trophy in a year where he was really one of the most productive quarterbacks in the nation. The next year, they led the country in preseason football power index. That was the first sort of year we had that. They had won the national title, returning Winston and a bunch of other great players. Then you can see sort of this headline here about offense and defense later in that same 2014 season. They weren't as dominant as the title year, but what they just kept winning because if the offense played well, the defense would. If the offense played poorly, the defense would pick them up, and vice versa, which is what you can see with this sort of negative correlation line. And some other interesting things we had done. This was for the championship game against Auburn. So. Big picture, when you build sort of a framework, right, which we started with expected points, now you can take expected points and build team ratings. You can build quarterback ratings. If you have team ratings, you can build preseason team ratings, right? Now you can make projections, and then you can talk about resumes and all these sorts of things. So this sort of like one thing kind of builds on another. Now you have a suite of metrics, right? And this is what we really saw with college football, a set of metrics that can tell stories about all aspects of a team's play and touch all sorts of conversations around college football. So this was hugely successful. College football, was and is a huge part of ESPN's business, and we were able to serve content, across TV, digital, audio, ESPN, the magazine, all sorts of places at the time by doing these sorts of things. And again, FSU, at that time was very popular. Sort of declined since then, but hopefully, there'll be another time where they'll be getting the headlines like these once again. And then just to talk about one other interesting sort of statistical project at ESPN that I worked on. And I should mention all these ESPN projects I worked on. I had tons of great teammates who worked in data management aspects, programming aspects, content writers, good leadership, data people, and on-air personalities who are super supportive. So they all deserve a lot of credit here. I should have said that at the beginning. I want to make sure that's clear here. So soccer. We worked on multiple World Cups. And the way the World Cup works is that in the group stage, you advance based on your record, but you only play 3 matches. And therefore, a lot of times you need tiebreakers. And when you need tiebreakers, it means how many goals you scored or allowed are important as well. So when you do projections, like we kind of talked about in the college football case, often it's good enough to say who would win, what percentage of the time would they win. But in the college case, in the soccer case, you actually need the number of goals they might score in the game. So you can see this grid at top right. This is the output of a more intricate projection model using a bivariate Poisson distribution. Poisson for counting, bivariate because you predict both the team's goals and the opponent goals. And basically what you want is the probability of each one of these potential results. So you can see this little grid here. The yellow represents ties, right? Draws where teams and opponent scores equal goals. Green represents the wins for the team, and red represents losses for the team. So you have a statistical problem. You can solve like part of it using the Poisson distribution. But then if you want to simulate forward the entire World Cup, you need to do the group stage, you need to account for tiebreakers, you need to know about the elimination round format, these sorts of things. This becomes a really interesting programming exercise, and something that I had to really work and build up my skills on at the time. But if you do it right, now you have these updating projections that after every match can run. We see this thing called what if analysis. So early in the group stage, there may be some questions about, okay, what if the team we were most interested in at the time, the USA, what if they win this match? What if they lose it? What if they draw? How does it affect their chances of advancing and moving on to the next round? So if you set up the simulations in the right way, you can answer all these sorts of interesting questions. You can see these visuals here. We were able to partner with 538, who did a great job with their sort of data visualization team to build these interactives where you can say, okay, this is how likely each team is to be first in their group, second in their group, and move on under different scenarios. So again, a really cool use case here with soccer. You can build, again, on projection models you use, but also think about what's different here and what you need to do differently to answer the same type of question. All right, so I want to pivot here and talk about my current job. So like I said, I'm a data science developer advocate at Google Cloud. And that's a mouthful, for sure. And it doesn't technically say sports, but I said with sports, right? So the general idea is to talk about Google Cloud and how to use it for data science. And one way you can use it for data science is to use sports examples or work with sports organizations. So just let me get into it a little bit more here. So Google Cloud, high level, is a combination of hardware, right? Computers, data centers, and software, products, tools that allow you to do data analytics, to store your data, to do various types of computations, build apps, do artificial intelligence and machine learning, right? So a bunch of software that goes with the hardware and put it together and you get Google Cloud. What does that mean for data science, right? So one sort of high level definition of data science is the, sort of field of taking data and turning it into insights, right? And what does Google Cloud do? Well, it allows you to turn data into insights, which many of you maybe do in your roles, but it allows you to do it faster, easier, and at greater scale, right? So we'll talk about a couple examples of how we achieve those sorts of faster, easier scale and on actual sports projects, right? And then the other thing that's relevant here is that Google Cloud has a bunch of partners who are sports organizations, sports-related organizations. So we've partnered with the NCAA, the Golden State Warriors, MIT Sports Lab is a group at MIT in Cambridge, an academic group that works on cool research problems, working with actually a bunch of other organizations, and they use the Google Cloud Platform as their main sort of platform for analysis. The bottom right logo here is the FA, the Football Association in England, or is what we in the US would call soccer. And then top here is our newest and sort of one of the more headline partnerships we have, which is with Major League Baseball, and I'll get into one use case with that in a minute. So with the NCAA, we're able to have a multi-year partnership to talk about mostly the basketball tournament, right? And we built on it year over year. One thing that we were able to do last year, which was a difficult year with the NCAA tournaments being canceled, was actually take everything we had built in the previous year, some of the team and player metrics, and also apply them from the men's game to the women's game. And when I talk about team and player metrics, some of them were similar to the ones we had talked about from ESPN, right? So in college football, you have a rating for how good a team is, how good their resume is. You can do the same sorts of things in college basketball. You can also rate players based on their overall quality, and you can use similar techniques to adjust for their schedule, right? Who you played is really important in how well you perform. And you can see here, so last year in women's basketball, we had a player, Sabrina Ionescu, now with the New York Liberty, the WNBA, who ranked nearly 3 wins ahead of all of anyone else in women's college basketball, and she was, of course, the player of the year. So having a way to quantify this was really cool. And again, from the women's game, which doesn't get as much coverage, was really differentiating and interesting. So content that was built on this was used, again, two years ago in the 2019 NCAA tournament, the last tournament that was played. And they were able to use some of our metrics about the 4 factors or how much time a team spent leading that was built using Google Cloud tools, and use them directly on the tournament broadcasts. And then, last year, small upside here with the tournaments canceled, which is obviously a big disappointment, understandable given the pandemic hitting at that time. We were able to simulate the NCAA tournaments. This was a really interesting task using Google Cloud tool called BigQuery, where we would build a model, again, using sort of predictive metrics for how each team would win the game. But you want to kind of simulate out each tournament. And using the way BigQuery scales, it was easy to not just build a few simulations, but also build 40,000 simulations, right, for men, for women, using different bracketologists, predictions of brackets, because, again, we didn't have the brackets. And here, I'll show you there's one sort of simulation that was made available here. And as you notice in that simulation, Florida State, again, trying to cater to the audience here, was the national champion in the simulation. You would think I picked this just for this presentation, but actually my alma mater, Boston University, which was a 16 seed in some of the brackets, in this particular one went 3 rounds to the Elite Eight. So it was actually picked from that, but also so I saw that Florida State actually ended up advancing. So this was a really good simulation for yours. So again, we didn't have the real tournaments, but again, we can use data science and some Google Cloud tools to create a series of fake tournaments and kind of convince ourselves of this is what would happen. And Florida State's basketball is looking pretty strong again this year. And fingers crossed these tournaments will go on, and hopefully they'll have a chance to really prove it out on the court. Okay, so another project with a partner we worked on more recently is MLB. So Major League Baseball has a player tracking system called Statcast, which tracks the position of the players and the ball multiple times a second. And they've had this system for about 5 or 6 years now, and they've done a really good job actually over that time of building out new metrics from that system, of making those metrics available in various forms to the public and to their own internal content researchers. And some of those researchers, what they will do is create sort of storylines and content off of these metrics. Some of those are in terms of game notes. So in a sort of normal MLB season, there are all 30 teams play almost every day. So there are 15 games to serve. People are broadcasting those games locally or on national broadcasts, and someone is tasked with giving them some game notes. Statcast data gives a whole new set of data to give game notes for, so the MLB content team generates some of these notes for each game. But of course, there are lots of games and not as many people, and each note takes a while to generate, right? So it can take, some games, you might cover the biggest teams or the biggest games, and then some teams may get a little bit less coverage. But in theory, there are actually lots of notes about players in those teams, right? Someone is good at something, someone is maybe not so good at something, a team ranks high, and if you look across enough categories, and of course MLB, history of being a data-driven sport has a lot of categories, and there may be something there that's worth highlighting on the broadcast or even on social for the team, right? So you can see the example of the note there, where it's about, this was during the postseason last year, sort of rising star Randy Arozarena of the Rays. He had had the most hard hit balls, right? So this is something, a Statcast stat about how often a ball comes off the bat with 95 mile an hour or faster exit velocity. So this stat, right, this is a thing that someone can look up. They can look up the table you see at right here about who had the most hard hit balls. The key here is that what we did working with MLB is to automate the creation of this stat. So this whole thing comes from a system where data is ingested into Google Cloud BigQuery. BigQuery looks across various statistics, assembles thousands of leaderboards, picks off the most interesting players of those leaderboards, and then also extracts out each piece, the context needed, talks about the definition, and surfaces the notes. By the end of the season, we had added enough stats and notes that you would get stats in sort of categories, regular season, postseason, these sorts of things, that you would end up with a couple hundred notes for some of the postseason games, right? So teams like the Dodgers ranked, in the race, naturally they got the World Series because they're good. So they and their players would rank fairly highly in some of these statistics. So you can then, automate some of these creations of these storylines. So the difference here, right, is you have some really interesting statistics, right? This isn't quite the NCAA case or even some of the ESPN case where you're making the metrics. Let's imagine you have the metrics, but now you have this like incredibly big dashboard or tool where you might want to find all these interesting notes. But you may, there's still only limited time. You can find anything, but you don't know what to look for. This sort of idea, right? And this is again powered by sort of BigQuery, our relational database tool, will allow you to go one step further and automate the insight generation, right? It has to follow certain patterns, but now you get a sentence, you get a table, right? And then those are delivered to you. And you can imagine how these can be set up to be different for different teams, right? Or different broadcasters. If I'm looking at one game, I only care about this. Or maybe I'm a fan of a certain set of players, so I can only look at those. And you can see how this type of thing leads to content personalization and things which leagues, media people are very interested in these days. Okay, so hopefully you get an idea of some of the work I've done both at ESPN and Google Cloud. And like I said, said with ESPN, the Google Cloud work is also super collaborative. I'm lucky to have lots of really intelligent people, lots of great tools at Google Cloud, and this awesome partnership with Major League Baseball to help enable these sorts of interesting projects and outputs. But let's talk a little bit more generally about sports analytics in general. Those of you who tuned in, maybe students looking to think more about the field or how to get involved, or just generally interested about what are kind of ongoing areas of research, right? So one perspective I didn't discuss here, right? We talked about tech perspective, media perspective, maybe the league perspective a little bit, but we didn't talk about the team perspective. So, like I said, I've done some consulting and advising with teams, and there are lots of different ways you can help a team. And the good news is that there are many more analytics positions that are on the team side, both on the business side, and then what I'll focus more on here is on sort of the gameplay performance side. So one way to get started, and you can do this if you're a college student now, is sort of recording some data yourself, right? So some of the really cool like tracking data and things I talked about are available for most pro leagues. Maybe not so much college, and depending on the level of your college or what sport, maybe not much at all. So the simplest way you may be able to get involved is to record some data. What does a coach think is interesting? What do you think is interesting about the sport if you're a fan? And maybe if you start recording it, you can start helping them. And if you can do this in the context of your school's athletic department or a class and lead to an interesting project, that would be great. And then when you're working with a team, you want to start with sort of like, what kind of questions do people have, right? These coaches, the scouts, the front office, these are people with tremendous expertise in the sport and often lots of experience. So they may not exactly know what data can do for them, but they will have really interesting questions, or they may have problems to solve, right? You always need to figure out your lineup. If you're in the front office, you need to figure out who to draft, who to sign a free agency, how much to pay them, those sorts of things, right? You still have those fundamental questions that need to be answered, and you, as the analyst, can think about how to use data to do that. So of course you evaluate your teams and players. You could project players again here. I'm not totally pandering, and although I kind of am, this was the thing I helped work on at ESPN with projections that were made for those going to the draft at this time. So this was several years ago. How likely were they to succeed in the NFL? And those sorts of things are really important on the team side, of course, right? When you want to make a decision about a franchise quarterback or who you should draft or sign. Team and player evaluation. This example here goes again several years back. Villanova and North Carolina are playing the title game. You can talk about like how not just how good is a team at shooting or rebounding, but how important is shooting or rebounding to their success. So again, this is very much in the sort of opponent analysis sort of thing where you're going to go play an opponent. What are their strengths, weaknesses? What are things you can maybe affect to maybe help your team move the needle a little bit in terms of winning the game. So, it comes down to helping teams win. There's lots of things. The same frameworks we talked about, right? Across sports, and the same ideas of capturing insights are important, but there may be a whole different way, sets of questions that are really important for teams than for media, than for leagues. Okay. So this is, again, my opinion of some important skills that I think help with sports analytics. So like I said, the good news is the field is growing. It also means the field is very competitive, and the bar to get in and to stay sort of on the top of the game is always the bar is always raising. So sports knowledge, of course, is super important. Knowing the rules of the game, knowing sort of generally the trends of what's going on. Now there's an ever increasing knowledge of sports analytics specific knowledge, right? So having some idea of what are the key metrics, frameworks, known things in certain sports, right? Fourth down decision making in the NFL. Why is that such a big topic in analytics? Mid-range shots versus 3-pointers in basketball. Knowing something about that is really significant. Then we'll talk about sort of these sort of harder skills, right? Data engineering, statistical analysis, and general sort of coding. When I say versatility, what I mean is if you go back to those examples with like having to code World Cup tiebreakers, it doesn't quite fit engineering, doesn't quite fit machine learning. It actually is more of like a software engineering task where it's like what we need to do is like be able to codify this set of logic into a thing that gets me what I want, which is the chances of a team making it out of its group or making the playoff or whatever. And for these sorts of harder coding tasks, the languages you see at the right here, SQL, R, Python, those are the three that I think I've used the most and I would recommend for data science. I think the general advice is to learn one of R, Python really well, and then SQL I think is super underrated and super useful. BigQuery, which I was talking about a couple minutes ago, is SQL based. So I think you can go a lot by using that, but learn one really well, get exposure to the other. SQL is probably the easiest to pick up after you get into a job, but having some exposure to all these as possible would be great. And then, asking good questions and communicating results. So this is something that is kind of stated at every sort of industry conference. If you go to the MIT Sloan Sports Analytics Conference or any of the big ones where there are people there who are high-level decision makers who are now increasingly interested in data, but not ones who necessarily speak data or statistical analysis or machine learning or cloud technology. They're going to, probably judge you based off what kind of questions and how do you communicate the answers to them. So this is always important. There's definitely lots of good sort of talks on this and advice on this, and I would encourage you to think about that as well. And then the biggest piece, like I said, I got involved in this field over 10 years ago, and what I knew at the time was definitely not enough to make the progress I've made to date, and what will likely be the next set of things to learn is still in front of me, and that is true probably for all of you as well. So make sure you have the mindset of continuously learning. I put these 3 languages up today. It may be a few different languages or totally new ones in 5 to 10 years. So just stay fresh and try to keep the energy up to learn as much as possible, and then you'll be surprised at how far you can go. Okay, so what are the areas of opportunity in sports analytics, sports data science? So again, these are my opinion. Some of these I have added to this slide, some I've taken off, some I've re-ranked. So this could change, all the time. But these are some things I think I've seen over the last couple of years that are really interesting. So often when we think of data, we think of tables, right? Rows and columns, numbers, etc. But there's also other kinds of data, right? So video can be data, text can be data, right? The image at the top here is from NFL's next gen stats player tracking data, right? So that's basically the art of taking video, or in this case, sensors on the players, and turning them into stats, right? And what if you don't have the sensors? Can you take video and turn them into data? There are obviously lots of interesting companies doing this. Google Cloud has tools that does this. Google Cloud has tools that takes text into data, images into data. Other companies have the same thing. That is a really big area of opportunity, in my opinion. How can you take things that are not considered data and turn them into data that could be used for the types of tasks we talked about earlier? Sports science and injury prevention. So, particularly in all sports, but you've heard a lot about this term load management in the NBA, resting players. There's some science to that. It's still fairly new. I think a lot is being studied in terms of what data should be collected there, right? So there's a medical piece to that, but there's also a data piece. What if you had more data about this? What if you had more granular data, and how can you prevent injuries? I think there's a lot of open questions in that area. As gambling becomes legal across the United States, obviously it's legal in many states, and I think more will come. You'll see a ton of sort of interest in that area. Companies, startups, bigger company, sports media companies also getting much more involved in the space than they have in the past. So that's another area, obviously very quantitative, right? Gambling is, who wins, who loses, or maybe these newer prop bets, daily fantasy, these sorts of things. In-game wagering, right? It all comes down to data. So I think it can be a huge area for, increased attention in the sports analytics field. Machine learning and artificial intelligence, right? I work at Google. This comes up in literally every area of study we do and every product we have. So virtually every product we have. So Google Cloud, is sort of the leader with machine learning and AI tools. And certainly there are applications in sports. And then I'd be remiss if I didn't kind of mention the last thing, which is kind of no matter how sort of complicated or sophisticated statistically, maybe you make the best metric, maybe you have the most interesting data, you have these really cool, injury prevention metrics or gambling insights or whatever it is. A lot of it is going to be integrated into decision-making, particularly on the team side, but not only there, right? So how can you take this analytics integration and then put it into what has to be done? Which player has to be signed? Which content should we use, right? Going back to the league or media case, or which, bets should we offer, right? In a gambling case. So how do we integrate it into the decision-making process, right? In the end, someone is going to do something. How will analytics influence that? And that is probably going to be an area of opportunity forever, right? Because you still, in the end, need to integrate that into what is the actual problem and what is actually going to be done. So lastly, how can you get involved? So, I told a little bit of my story, but I'm getting, older as we go, and my story is not as relevant. The ways to get involved now are way more numerous than even 10 years ago. So, many schools, including obviously Florida State, and shout out to this summit right here, have their own sports analytics clubs. They held their own events. They have courses on sports analytics at some schools that I've seen, which are really cool. Any ways to get involved like that, I think, are great. You can essentially think about all the schools, techniques, programming languages, things you'd learn, and apply them to sports if possible while you're in school. Then there's this sort of competitions or events, right? So I have an example here of the NFL's Big Data Bowl, which just wrapped up recently, which was a competition on Kaggle, which released a bunch of that next-gen stats tracking data that I talked about to the public, and you wanted to evaluate defensive player performance, right? So this is directly a way, and also should mention there's prize money. There's directly a way to basically showcase what you can do with some cool data and basically put yourself in front of people who may be looking to hire or eventually looking to hire on analysts for helping them, with NFL data. So that's one. There are other events just like this. And then, sometimes with Big Data Bowl, other options there's a lot of publicly available data, and then you can publish in things like journals, right? So there's a journal of sports analytics, multiple conferences, right? I spoke about the MIT Sloan Sports Analytics Conference. They have their own sort of research paper track, and they publish those papers as well. Again, these are ways to kind of not just take your research, but put it into a forum where it is accessible by others. Of course, you can also do your own blog and social media and all this. I think that's great. This is, again, just some unique ways to really put yourself in the public eye, so to speak. And the last one, and this is something I hadn't, it was pretty foreign to me several years ago, but now there's a lot of open source, not just data, but code and public analysis, right? Especially with the advent of sort of NFL Twitter or all these other sort of people sharing their analysis online connected to a specific sport. So you see this NFL FastR, which is a package in R that allows you to get NFL play-by-play data. But you can also build packages like this, or you can contribute to them and sort of see what's being done there and learn, and also make things easier for other people. So, right, we talked about the data science process, all the sort of different steps involved coding, right? If you get really good at data engineering, that's actually a valuable skill set in and of itself, even if you're maybe not the most experienced at statistical analysis or machine learning. So, contributing to open source code and doing some public stuff is also really an interesting path potentially for this. So that's about all I had. Thank you so much again for having me. Hopefully you learned something about sports analytics and data science. And if you have further questions or would like to reach out, I'm on Twitter and LinkedIn, and I look forward to continuing the conversation with all of you there.
Alrighty. Well, Alok, thank you so much for joining us today for that awesome presentation. And we just have a couple more follow-up questions for you, just to get a little bit more of that kind of background information and the stuff our students want to hear. So we can go ahead and jump right in. One of the big points from your presentation that kind of struck me was the importance of asking questions, and specifically of asking good questions. Pretty much, unless you live under a rock, we're hearing millennial this and Gen Z that. You personally, have you seen a difference in how inquisitive people have been, or really are, from generation to generation?
Yeah, I think a lot of it is, we're talking in the data science framework, right? So I think everyone kind of knows that you want to ask a question of your data, but depending on who you're working with, it may be different questions of the data, right? So if you may be working with a team of analysts who are millennials or Gen Z, and you're used to thinking of things that way, but you may, in sports, right, go and talk to someone who is a different generation, a different background, right? Football coaches, basketball commentators, whoever they may be, and they're going to ask the questions in different ways. And if you're, as an analyst, as you gain experience, one of the things is you want to learn how to translate what they're saying into analysis projects for you to do. So I think it's like kind of marrying their questions with your questions. You might be coming at it from the data angle. They're coming at it from like a real world sports angle. And I think trying to have that translation in your head. And then once you do the analysis, again, on the other side, take those answers back and translate it into their language and the way, what they're expecting to hear.
Absolutely. Next question for you, more on kind of your specific role. How are you personally measured at Google in the organization, and what would success look like in your specific role?
Yeah, a great question also. So we have a very comprehensive performance review process. So that's kind of, twice a year that I get truly measured. In my current role, there is a lot about, trying to keep what we do that is measurable and make sure we measure that. And also keep in mind that what we do in developer relations is often not directly measurable. So a lot of times it's output, right? So in my case, if I do a talk on sports analytics at Google Cloud, or even a non-sports talk about how to use a particular tool, it will be, how many people did that talk reach? How many, if it's with a specific customer, how many people at that customer then engaged with that product? If it's more public, it'll be how many views did it get? How many people were at that conference or that event? If you write a blog post off of that, what can, what were the sort of metrics on the blog post? But also keep in mind that, other people may be using it and you don't know the impact, where our customer engineers, our people in the sales and in the field doing sales may take that content and reuse it. So we try to track that as much as we can. So success in big picture for Google Cloud is adoption and mindshare, inspiring people. Can't really measure that directly, so we have all these proxies to measure it, and that's kind of what overall success looks like. From sports standpoint, I look to do innovative stuff, cool stuff, new stuff, building on things that I know from the field, what I know from tools, and usually you can tell from people coming up to you and be like, "Oh, that was cool. I hadn't seen that before. Didn't realize BigQuery was that fast, and I need to think about it." And that's kind of my personal success.
Absolutely. And speaking to BigQuery, that was one of the things I was incredibly excited about in kind of our initial talks. There was a specific example that one of your big queries churned through, I think it was something on the order of 1.5 terabytes of data in just a few seconds. And I think that's something that's very, very cool, super kind of applicable to the world of big data, and really exciting to see that technology come to fruition. Another question
totally
too. Oh, pardon. Another question too. It's obviously a little bit difficult to think back exactly to when you apply to your current role and be able to kind of pull up that job application out of the back of your mind. But when thinking about your current role and kind of how that was described, your idea of it when you applied, what did you maybe not expect to be doing in that role, and how were you able to kind of pick up those skills on the job and acquire the knowledge that was necessary?
Yeah. So I'll talk a little bit about a couple, like the initial job I had at Google and then this job. And both, what makes it challenging is they're not coming in and expecting you to, for the most part at Google, to be like, we'll tell you what to do and you do this. They have big picture questions or things that they want to satisfy, goals they want to achieve, but it's kind of up to you to figure out how to achieve them, figure out what tools you need to know, figure out what questions you need to ask, and who you need to talk to. So I think to answer your question, figuring out what I needed to know, it's kind of this meta point. I had to figure out what I needed to know. That was the thing I didn't realize going in. You think you can just hey, I will look up this in the manual. It's not that there aren't manuals. There may be too many manuals. There may be not exactly the right one for the thing you want. So I think the biggest thing is to have this continuous learning mindset. Don't be afraid to ask a question, and then keep building on it actually, and ask several questions, because you might think that everyone knows the answer, but actually what you might be getting at is that there's this pocket of knowledge where there isn't a clear answer, and that's actually where you want to kind of dial in. So knowing that I needed to keep pushing myself to learn more and figuring out what exactly is to learn is probably the biggest thing at Google in particular.
Awesome. And again, touches back to that initial point on asking questions and asking good questions. Next question, we hear a bunch of whole next big thing and a bunch of buzzwords. One thing that comes to mind is GPT-3. So kind of when you were leaving college, new in the professional world, back with your time at Gillette and maybe even early at ESPN, can you think of something that was the next big thing when you started? Has it turned out to be the next big thing? Has that kind of changed?
Yeah. Not the most tech forward person to know exactly what, now that I live in Silicon Valley, I a little bit more aware of what is the next big thing than I was at the college time. Analytics was considered a really big thing, and certainly in sports that has taken off. That's why clubs like yours exist, right? And then machine learning is certainly not really the next big thing. It's the current big thing in tech, and I agree that has kind of gone forward. I think the sort of mindset that I think is most valuable is where, if you are working in this field, where will that next big thing touch you? So if you're there's tons of people doing lots of great research on machine learning in universities across the world and at Google and other companies, right? I don't particularly do that type of research, but what outputs of those, or what things do I want to do? In my case, I want to apply it to sports, right? So what do I need to learn to apply that to sports? So when you hear about whatever is the next big thing, if you're working on it directly, awesome. If you're young enough in your career, you want to attach yourself to that, great. If not, see how it kind of affects your role and incorporate it accordingly, I think.
Awesome. Another question, and you definitely touched on this a lot in your presentation as well, but what would you say is one of or some of the most innovative parts of your job that you are able to share with us? Maybe something that you don't know that anyone else is doing in the field.
Yeah, I think it's some of this working with the partnerships we have. I talked about NCAA, and now I'm working with Major League Baseball. It's getting really deep into like the types of data that they collect, some of which is like, focused on sports and people know about, but some of which is more internal to them. And then bringing these like really like innovative tools to actually like solve those problems at a scale or in a way that hasn't been done quite before. Right. So I talked about like the game notes project, and it's like, they have game notes, they have data, but like, how can you take that from like this sort of like semi-automated manual process to another level of automation and really like up level? And you can think about going a couple steps further from there, where they might be live notes, right? The data happens on the field and automatically context is coming. So it's solving these like authentic sports use cases using technology, where you really need to use like data science knowledge, Google Cloud technology, sports knowledge, and it's like an interesting, to fans or to teams or to the league. So it's kind of this nexus of those things that I think is the most unique and innovative stuff that I'm able to work on.
Awesome. And a little bit more generally, what for you has been the most exciting part of your career at Google or otherwise?
Yeah, I think the most exciting part of my career to date, hopefully there'll be plenty more, was getting to be a founding member of the ESPN sports analytics team, which we talked about in the talk. It was just like at the time of where I was in my life, and the amount of learning and just like it being new and creating a quarterback rating where there was nothing, and at a time where ESPN was very supportive of that sort of metric. And we launched it with a TV show that was hosted by the current Monday Night Football crew, and like things you couldn't like kind of dream when you were in school, like majoring in statistics. And that was happening, right? And then from there, working with the college basketball production crew and like getting to learn that stuff. That was probably the most exciting time. I was learning a lot, had great colleagues, had great support. As I've gone through my career and as others have too, you find excitement in different things. The same thing that excited you when you were maybe right out of college won't necessarily excite you later. So now a lot of the things that I find exciting are more of this like opportunity to learn and push myself, and like, I didn't know anything about this, and then maybe a year down the line, 2 years down the line, be like, hey, I actually know a good amount about this. That's what I find currently more exciting.
Absolutely. That's awesome. Alrighty, and final question for you, and please feel free to incorporate any final notes as well. Totally generally not related just to sports analytics or your current role, but what are you most excited for about the future? I know that's a pretty big and open-ended question.
Yeah, no. I currently, right, we're in this pandemic state, and it's been fairly difficult and I guess like sort of isolated, right, is maybe a way to describe it for the last year. So I guess my current hope for the future is that we emerge from this, and whatever role data, certainly science can play in this is great. And hopefully like, I think it's, kind of naive to assume it goes back to normal, but maybe there's things out of this, like these virtual summits that provide value, and we can actually take the sort of things that had to happen and that we had to adapt to and make a better normal in the future. So I think that's probably my best answer to that question right now.
Absolutely. Well, I really could not agree more. Well, again, thank you so much for your time with the presentation, and then additionally coming back to humor us for a little bit of Q&A. But thank you so much for your participation. I'm sure our students are absolutely going to love what you've had to say, and we'll hope to see you back again in the future as well.
All right. Thanks for having me.
Absolutely.